Good afternoon. My name is Diana Lee. I'm the Federal Program Manager for High Temperature Reactors. And today I'll go over two NEOP scopes, one for high temperature gas reactors under RC-4.1, and the other fluoride salt-cooled high temperature reactors under RC-4.2. So going right into high temperature gas reactors, our experimental validation program is focused on developing system and computational fluid dynamic models, but we still lack high quality data for validation. We want to understand behavior during transients such as forced cooling transients, which may or may not occur with a break in piping or components. And in order to validate our models, we need separate effects tests, mixed effects tests, and integral effects tests. And these need to be properly scaled so that they reproduce the thermal fluid conditions we expect during nominal and accident scenarios. So for us, that means that we scale our facilities to the General Atomics 350 megawatt modular high temperature gas reactor or the 600 megawatt gas turbine modular helium reactor. Now for integral effects tests, we don't expect NEOP scopes to cover that. It usually is much funding and resources to create facilities for integral effects tests, but we do have several facilities already available. One example is the high temperature test facility at Oregon State University. And the other one is the natural circulation shutdown test facility, which is at Argonne National Lab. Additionally, NGNP Alliance and DOE are sponsoring investigations of reactor building atmospheric response to leaks through an industry award with Texas A&M and Ultrasafe Nuclear. Now, HTTF and NSTF are scaled to the modular high temperature gas reactor, and the Texas A&M Ultrasafe study is using the gas turbine modular helium reactor as a reference design. So for fiscal year 18, we have two areas that we would like proposals in. The first one will look familiar because it was in our call last year, and that's for proposals that will investigate natural circulation of hot helium plumes and jets within the reactor vessel during an extended loss of force circulation. The other area that we would like investigation is for partitioning of water in the primary loop after a steam generator tube rupture. We're particularly interested in the sensitivity to the rupture location and want to understand the form of water or steam that's entering the primary loop. So all investigations should include experimental and computational studies of separate and mixed effects associated with the phenomena that you're looking at. And scope that has significant experimental data will be considered with higher priority. Also, as usual, all experiments should be performed to NQA1 standards. Now moving on to fluoride salt-cooled high-temperature reactors. Oak Ridge currently has a functional high-temperature force flow Flynac salt loop, and in fiscal year 19, they were planning to have a force flow fly loop available as well. So just like the high temperature gas reactor scope, we're looking into two areas for fluoride salt-cooled high temperature reactors. The first is involving the loops that I just mentioned at Oak Ridge. We're looking for proposals that will design and execute experiments related to corrosion, instrumentation demonstration, thermal hydraulic data, or dynamic system model verification. Now, running of the actual loops at Oak Ridge will be funded by our own program funds, but we're looking for your proposals to have specifications on any additional hardware that will be needed and how you'll collect, analyze data, and document the results. And the other area that we're looking for with respect to FHRs is reactor core and plant modeling capabilities. So some areas, but we're not limited to them, that we're interested in include core neutronics, thermal hydraulics, and dynamic system level modeling. Again, all work should be performed to NQA1 standards. And if you have your models in a form that can interface with the NEAMS toolkit, then we'll consider that with higher priority. So that's all I have. I believe for high temperature gas reactors, our National Technical Director, Hans Gauger, is listed as a contact on the slides. And for FHRs, we have David Holcomb, who's our technical point of contact, and I believe they're on the line, hopefully, so if there are any questions, they can help me answer.
We will be taking questions on the question and answer box on the NUP, excuse me, on the GoToWebinar. I will be making Hans and David Holcomb available. Hans, are you there? Is your mic unmuted now?
I know. Can you hear me?
Yep.
Oh, good.
And yes, here, David, are you there?
I'm here.
Okay, great. We have both of you now to answer questions, and I know that we have a few, so we will start out in RC 4.2. Will advanced modeling on MSR be considered in this area?
So if the scope is complementary to FHRs, like it will actually be applicable, then we will consider it, I believe. But there is separate NEOP calls for MSR specifically. So, David, if you want to give any more input to this.
That's a programmatic question, and you gave the answer, which is focus on this is FHRs. If it also is supportive of MSRs, that's good. But right now the focus on this is modeling and capabilities that support FHRs. Obviously, there's substantial overlap in the technologies.
Continuing with RC 4.2 questions, is there interest in measurements of optical properties of molten salts versus temperature?
That was a
certainly we
had last year. Go ahead, David. Sorry.
Yeah, you can give the history. Yeah, that's correct answer.
I'm not sure what the NEOP scope is for the MSR specific scope. We'll just have to again see.
Well, your question, the just awarded the they're in the award process, but they just were announced the winning of the FY17 awards, and Luca Scarlatti at University of Wisconsin won optical properties of molten salts as a function of temperature. So we're not seeking to explicitly replicate that effort. So that particular instrument was the subject of this last year's call.
Is there interest in development of thermal radiation transport modules for existing thermal hydraulic code in the NEAMS toolkit for molten salts?
That sounds
again.
Again, we'll have to see if it's specific to fluoride salt cooled high temperature reactors.
And the issue again is look at what the call was last year and what the awards were for last year. We're not seeking to have the same capabilities developed that we've got an ongoing project or just initiating project trying to resolve.
For FHRs, which designs are you pursuing for modeling and simulation? An example, pebble bed or prismatic types?
David, if you could answer that.
We are seeking to support general capabilities on there. Certainly, there is now a U.S. vendor looking at a pebble bed model, so we would be interested in being able to support the U.S. vendor, but there is not a specific capability, reactor design that we're trying to support. We're trying to develop the capabilities so that to be able to support any FHR design.
More questions in RC 4.2. What materials are of interest for corrosion testing?
We are interested in generally the nickel-based alloys, or if you have a corrosion control scheme that you're trying to promote, which would be for an iron-based alloy to indicate that's one of the other alloys which are compatible with an FHR. So we're looking at alloys which you might use for an FHR primary salt wetted containment.
For RC 4.2 flow loop testing, will the hardware purchased with R&D funds belong to the university, but could it be allowed to be installed at the flow loop at Oak Ridge for testing?
I don't know that that's a technical question so much. I mean, we're not seeking to acquire components at Oak Ridge. If you want to temporarily install something, after you're done with the testing, we would. I don't see a particular reason that it wouldn't be following the normal contracting process. But contracting questions are best answered by Diana.
And we will defer that question. We can answer that with our contracting folks at a later time. On RC 4.2, does a proposal need to cover both of the two topics, flow loop and dynamic modeling, or only one topic?
Only one topic is expected. They are pretty different, so if you somehow find a way to cover both, we won't preclude you from that.
Is there interest in studies of the optical scattering properties of erosion, particulates, and molten salts?
I think that's a very similar question to the earlier questions. Again, we're tailored to fluoride salt-cooled high-temperature reactors, and we do have the previous year's scope on optical properties. So if you somehow find scope that can fit our needs and hasn't been covered already, then we can look into it.
And we're not expecting in an FHR to have a lot of suspended solids, so we're not expecting to have a substantial erosion problem. If you think that that's different, or you're trying to operate in some velocity regime where the salt itself is going to cause substantial erosion, then you'll have to also explain what your design rules are, because we are currently not expecting to see substantial erosion in essentially a clean salt flow.
Can you elaborate on what specific gaps that you hope to fill with these three areas? 1, neutronics, 2, thermal hydraulics, and 3, systems modeling.
I'll leave that to you again, David.
Well, they didn't even identify, was that RC 4.2 on there? Okay.
Yes, that was 4.2.
Okay, all right. Certainly, we're interested in having tools which are again, it's written right there. Tools are affordable, accurately, and easily shared among collaborating institutions. Again, trying to get things that are available for that. It generally are available to be more widely used. I don't know that that there's a great deal more information than the words which are sitting there. I'd have to get a more specific request. Dynamic modeling, the reason you do dynamic modeling is to help things like control design and look at accident progression. You do core neutronics modeling to understand the physics response of reactors throughout their life cycles. We have the standard set of reasons why you want core neutronics models. We don't currently have things like a pebble bed core neutronics model in any of the NEAMS toolkits. We would like to have one. The thermohydraulics are not, we don't have very accurate thermohydraulic modeling for the fluoride salt flows. That is something we would like to address, having hydraulic modeling tools.
And we do have 2 integrated research projects for fluoride salt-cooled high-temperature reactors ongoing right now. It would probably help you to be familiar with their work in core neutronics so that you're not duplicating their efforts.
For RC 4.2, why does the NEAMS toolkit get priority over other projects?
The NEAMS toolkit is another area that DOE is focused on. So if we can work together and not double in efforts again, then it would make sense for us to go forward in that path.
This is an RC 4.1 question. Will the experiments proposed within this scope be limited to use existing test facilities in labs?
No, certainly there are advantages to using an existing facility, but it is not a strict requirement. What we have two large integral facilities that are somewhat related to the scope here. The one at Oregon State, and then the one at Argonne. What is missing, of course, in a large validation pyramid for any type of reactor plant is a lot of the separate effects tests that also form part of the whole validation matrix that would complement what's going on already there. And there are a number of NEIPs that have incorporated or have used their funds to build new separate effects facilities, and they've revealed valuable data. All that we ask is that we get a common scaling in it to one of the reference reactor designs, try to work with the integral facility designs a little bit, at least to come up with the scaling, and look for ways that the local separate effects or mixed effects tests the data can be integrated with the data that's already out there.
This next question isn't directed at either work scope. Are specific geometries of greater interest for heat transfer experiments?
Oh, well, that's an interesting one. You mean heat transfer through solids or through liquids? I imagine it's mainly convection in liquids, but there are some tests in the high temperature gas-cooled reactor, when you're operating under accident conditions, when you have a loss of forced circulation, where heat conduction becomes a little bit more difficult or more important. Now, we are considering in the long term of converting the high temperature test facility out at Oregon State, which is currently configured for prismatic reactor design, into a pebble bed configuration, and the heat transfer through a pebble bed is certainly a more difficult problem. There's a need for validation data in that area, particularly between the pebble bed and reflector interface. So there are some problems related to geometry and heat transfer that are relevant. It might be a bit of a stretch to focus them on the scope, the areas, the types of incidents that are spelled out in the scope, but it's not impossible, and we are open to all R&D proposals that look at the thermal hydraulics of high temperature reactors.
And certainly in assault, things like form losses in inlet plenums, outlet plenums, in bundles of tubes. There are a number of areas where it would be valuable to have some geometric form loss information for the molten salts to feed into the hydraulic modeling. We don't have very good correlations beyond the classical form loss function. So yes, some geometric things would be of interest if that's what the question's about.
These next two questions are for RC 4.2. Even though a NEAMS toolkit proposal is preferred, will non-NEAMS tools still be okay and potentially, or could potentially be funded?
The answer is yes. Of course, again, there's priority, so it just depends on who else applies. You don't have to use something in the NEAMS toolkit, but we are, again, hoping that your data can be in a form that can interface with the NEAMS toolkit. So I guess in short, just yes.
What specific thermodynamic properties of molten salts are being requested, and over what temperature ranges?
So David, can you talk about FHR.
Well, I don't know that there's, that there is a specific request on there. We're talking about going ahead and, whether, we're trying to use the loop and, and saying that this is a facility. So there are things like, pump form losses that are going on. The loop is an alloy 600 loop, so its intended upper temperature limit's around 700. So you won't want to try to do an experiment that extends beyond that. Some of the instrument, if you're trying to do a pressure drop measurements in the loop, would like to be work within the flow range and the resistance of the capability of the existing system. We're, essentially, if you're looking at, this is a FlyNac system, you can decrease the uncertainty on there, but I don't think you would be doing the loop to be measuring thermodynamic or thermophysical properties. You'd be using, vibrating beam viscometer or or laser flash thermal conductivity measurements for trying to decrease that, or Archimedes density. So I don't think that measuring thermophysical properties is something you'd really use the loop for.
Will international collaborations be looked on favorably for these scopes?
I haven't been told otherwise, so.
From a general NEUP standpoint, international collaborations are encouraged, but please be aware that international collaborators cannot receive U.S. funding. So they either have to provide in-kind resources or their own time, or potentially funding through their own government.